Okay. Hello, everyone, and welcome to another Grafana Office Hours. It's been a while since the last one, but this one's a special occasion because we're actually in person and there's no box.
But there is a hotel room.
Yes.
And it is an ungodly hour at 8 a.m.
Yeah, and I had to tidy up in my hotel room, even though you can't see that much from behind. But hi, I'm Nicole van der Hoeven. This is Dee Kitchen, our super special guest for today.
And
And
I'm
my
your partner in
co-host.
crime, always in trouble, Jake.
Just perennially in trouble. But Dee, why don't you introduce yourself?
I'm Dee Kitchen. I'm a VP of Engineering here at Grafana Labs. I run the databases team, which is Loki, Mimir, Tempo, Pyroscope, and some of the work around Influx, Datadog translators, Graphite, and OpenTelemetry.
Awesome. So how long have you been at Grafana?
5 years next week.
Oh,
No,
wow.
2
Wow.
weeks. 5 years and 2 weeks.
Congrats for your 5
Yeah.
years next
Thanks.
week.
That's a
What do I
lot.
get?
Nothing from us. Sorry. Maybe you should give us something.
I feel there is internal swag though for 5 years though, right? There is actually something really cool that you get at 5.
Yeah.
There is.
Like-
Do people know about this? Like that 3 years, we get a little light.
They don't
No,
actually.
no. Yeah. We get a little LED light. Mine's in Portugal. I don't travel with it. We get like shoes.
And then it's supposedly, I don't know the secret. Richie will not tell me what the secret 5-year item is. He refuses to tell me.
We'll find out what the 10-year is.
Yeah.
Well, Dee, tell us what you do. Like, we know your title, but what do you
Um,
actually do?
So I'm a manager, and a lot of that's people management, but the shape of a manager at this level, when you're at the VP or near CTO or kind of that level, it's not one-dimensional. Right? When you're an entry-level manager, you're typically doing the sort of health of a team. You may be doing some project management. And as you go up, you're also doing more customer-facing things. You're accepting and protecting some of the legal sort of things, like perhaps security and compliance. You're also looking after and shepherding other managers, which means nurturing and helping them grow so they can protect their teams and look after them and so forth. And throughout all of this, you've still got to be the holder of some product vision. You've got to know where you're going to go, what you're trying to achieve.
That was going to be my next question. It's like, how do you feel you juggle each of our databases? I mean, some companies only have one database they develop, and we develop 4.
So fundamentally, the architecture is similar. So conceptually, they're very easy to do. If I was trying to do what I do, which I manage 100 engineers or thereabouts, if I was trying to do this and I had wildly different products, like let's say a chunk of the Grafana stuff and a database, this would be too hard because they don't have alignment, they don't have similarity, there's no shared components. But the architecture of the ingest model and the read model is so similar between the sort of Mimir, Loki, Tempo, Pyroscope that you really only have to understand the signals. But I've been an engineer for so long that I understand the signals, so it doesn't feel too different from.
Well, we should probably say upfront that this is going to be about the direction of the databases. So that means there's a lot of things in the future that we're going to be talking about. Please don't hold us to any of this, because if you do, then we won't get Dee back on to talk about this stuff in the future if they think that they'll be held to what they say. We're going to be talking about things that we're currently investigating. Some things are already built. Some are already in GA. Some things are just conceptual right now. Some things are built for one database, but not for another. So, just disclaimer up front.
Yeah, it's worth saying that the engineering culture here is very relaxed. And there's a sense of urgency and a sense of prioritization, a sense of what's important, and we're listening to our customers. But we actually only ship things when they're ready. And we are willing to investigate something, perform an experiment, and say, that didn't work. There's something better. Let's do the other thing.
I like that. No vaporware policy.
No.
Well, I mean, I would hate to be in a company where that wasn't the case, where it was just like, no, we've committed to it and we're going to die building it, even if it's wrong.
Ooh. So I was at a company in my past, and part of the engineering organization would mention what they called Gartner-driven development. And that's this, the Magic Quadrant has done this. We must add that feature, and it goes on the roadmap. And there's no real passion for it. There's no real understanding why you need it. There's just we must tick the box, and we just don't do that. Right?
Yeah.
Grafana does not do that at all. We build the right thing. We ship it when it's ready.
Yeah. So you're talking about the architectural similarities between the databases. Maybe we could talk a bit more about like just in general terms. It seems like it was an ingester architecture, right? So typically we have like an ingester and a distributor and querier. There are things that are common across all four. At least that's how they all started. Um, is this something that you think is changing in the industry as a whole, or because we're sort of blurring those lines a little bit, adding some components in there?
Yeah, so the model of how we do this, and at the moment, some of the databases are still doing it in kind of a, I don't want to use the word legacy because it's still best in class, but it resembles more how Cassandra would do the sort of ingestion. Yeah, and it's more a typical distributed system. You've got a distributor. The distributor is going to sort of talk back to the client. It's going to then the distributor's job is to hand it to 3 different ingesters, and that's replication factor 3. And when you've got it handed to 3, then you can immediately, the distributor can act back to the client and say, we got your data. From this point, we cannot lose it, and everything is safe. And that's great, but you're running replication factor 3, which is kind of a high cost.
Yeah.
And it still leaves you at some risk. Right? You can lose an ingester. You can even lose 2 in the worst case, but you can't lose all 3. So if a CSP fundamentally has an issue, you're still at risk. And there is a sense in the last decade, 2 decades, that the industry has sort of consolidated around object storage as the data sort of storage of every single thing. And a lot of cloud native apps are literally object storage. That's what they really mean. But the new sense in the last probably about 10, 15 years is that the way to ingest is actually Kafka, right? It's the Kafka API. And that's all good, but Kafka had its own problems. And Kafka is difficult to run. Right? It's difficult to build that skill. You're still prone to the same problems. And a couple of years ago, what started to emerge were companies doing Kafka API. It's just the implementation of the API. So if you think about object storage, we think of the S3 API. But GCS, Google Cloud Storage, that implements the S3 API. But it's not AWS. It's not, it's just object storage. Right? So the API, the interface became the standard for storage, and the Kafka API has become the standard for sort of buffering. And ingestion is buffering. And now we can design new architectures, which Mimir has first, where basically Mimir is writing, the distributor writes straight to a Kafka API. Now we use WarpStream. There are other open source projects in this area. WarpStream is now owned by Confluent. And WarpStream is the Kafka API backed by object storage, which gives you the replication there, but it also gives you the durability guarantees of object storage. So now you have a choice over how you want to run that component. And that's a lot more flexibility, a lot more standard, and it opens up other possibilities. Like, because you can suddenly have multiple readers from it.
Yeah.
The ingester model is a little bit more simple, but out of Kafka, you get more flexibility.
So does that decouple you then? So in our current architectures, we look to basically have readers that will read the nearest data from our ingester components. Does this decouple our write and read path in these new architectures?
Yes, but and always there's a but, because you're speaking to someone from engineering, so we're just going to go, it depends. Absolutely everything. So yes, there is a decoupling that actually happens, but what actually goes on here is that in the first phase, right, if we wrote it from scratch, perhaps we would just come along and just go distribute it straight into a Kafka, the WarpStream sort of object Kafka API to our object store. And then we would just create different readers that come off the back of that, and query path would hit that. But that's a lot of changes at once.
Yes.
Yeah.
And any sensible engineer is going to slow down and go, don't change
everything.
Don't commit a PR, right, which is 100,000 files and 2 million lines of code. Like, don't do that. Break it down to small things and validate each thing.
Yes.
And then prove that piece with the least change that you can achieve. So the least change that we can achieve is that we can make the ingesters just read from Kafka themselves and put the Kafka in, gain all of the durability, reduce the replication factor on the ingesters, but today leave the read path to go to the ingesters as they were for the very most recent data. And that's the safest way of doing this because it's mission critical. Right? No one is going to use an observability product which isn't mission critical and that reliable. So we are not going to change 50 things at once. We're going to change one, prove it, gain reliability, change the next thing. So it's a very long path.
Exactly. Like if your alerts don't fire, that this is action stations because we're meant to be the ones telling you that you have problems, not the fact that we have problems because we've lost your data.
Yeah.
So I was curious how a change like this filters on through the databases. Is it something like that you said or that is set at a higher level and then all of the other teams try to investigate how to do it? Because to us, it just seemed like, Jay and I are more involved in Loki. So we heard about their implementation or trying to implement Warp Stream and Kafka and the decisions around that. And then it's like, oh, Mimir has done that. Oh, Pyroscope's looking into this. Oh, so it's like, is it just one person does it and everybody else follows, or?
So this goes back to the engineering culture within Grafana and especially within the databases. We give very high autonomy to engineers. And so I'm really not there. And Tom, my boss, CTO, we're really not there dictating. We're not saying you must do this. What we're saying is, have you considered? Would you experiment with? Do you think that this is something that could work here? And we might seed a thought or we might hint at a priority, but we actually give the engineers an unbelievable amount of space to choose the time and sequence of things. And for a while, everyone has come to it for a different reason. Mimir came to it because we would run a large cell and we might have 500 ingesters. And the reliability of ingesters and that model, when there was only like a couple of hundred ingesters, the reliability was really high. The anti-affinity worked well, everything was cool. But it gets disproportionately expensive. And kind of like how RAID gets less reliable at massive scale, the ingester model kind of has some of those sort of concerns around them. So they came to it from a reliability perspective. Can we get the Kafka API in and the durability of object storage? Loki has come to it from a perspective of, currently when they write 3 copies from the ingesters, they have to deduplicate that.
Yeah.
And there's a lot of work that goes on. And logs is a volumetric signal, right? So that massively increases the storage requirements, the IOPS that you're going to do this writing and deduplication, the burden on the sort of compaction type work that you actually have to do. And so, they came at it from a different perspective. Maybe we don't have to do this work if we only read once from Kafka and we can guarantee that Kafka has handled the replication and the durability, then it can streamline everything below. And that should also increase the velocity of the engineers because they don't have to work with always thinking of replication factor 3. Tempo came at it from a different perspective because Tempo are also a volumetric. And when I say volumetric, if you think about metrics and profiles, these things are aggregate. They send one bit of data X time period and it represents all the things in that time period. But with logs and traces, if you've got an API that gets hit once in a second and it logs 10 times and writes 2 traces, you're going to get 10 logs and 2 traces. But if it gets 100 times, then all of that volumetrically explodes. So Tempo also has this volumetric thing. They need to go faster. They wanted to simplify the mental model as an engineer. With Pyroscope, they wanted a streaming architecture to handle sort of the burst loads and sort of make it a little bit more reliable, but also increase developer speed. So they're all coming at it different ways. What we actually do is we share the expertise. Right? Our teams talk to each other. And on Loki, like Ed and Owen, they're going to go and speak to Marco on Mimir, and they're going to say, how did you do that? Like, can we learn from you? Like, we're actually at an offsite.
We haven't actually said this is what we're not just in a random hotel room.
I just invited them over to my hotel room.
So we're actually at an offsite and
a database is
on. And we've had these sessions for the last couple of days where they're actually going away into rooms and they're actually saying, what did you learn about how to use the Kafka API? What were the problems with integrating with it? What were the problems with the operationalizing, or we want our TCO to be low, and in part we want to maintain the margin, but we want to pass on that cost saving. So we want an effective sort of TCO. So we have to concern ourselves with what's the reliability, what's the cost, what's the speed and maintenance and ease of operation. So
Yeah,
and they all talk to each other.
there's a lot of like, oh, can we copy your homework? It's been going on, and that's a good thing.
Which gives us a good vibe.
Yeah.
Like, I really enjoy seeing them interact and go, well, hang on, why did you do that? And it's the curiosity between teams is what I like.
Yeah.
And then, there's the ability to be honest about it too. You can debate the fact that was that a sensible decision or not. So we do have a question, but I feel like we could hold that just a little longer when we start get into more specifics, especially around our databases. But before we got to that, we do have some initiatives that we've talked about at this offsite, and some things that we've already implemented our databases. And Dee, I wondered if you could talk a little bit about where we currently are, say, with OTel compatibility, where we're going from a more broader sense, and then maybe talk about some of those other features we've kind of implemented across the board, like drill down apps.
Okay, so which one of those do you want first?
Let's start with OTel compatibility. I like OTel. I'm an OTel fan.
So it depends on the signal. For Tempo, this is traces built on Jaeger. Jaeger was one of the first OTel signals. The maturity and OTel's traces were so influenced and derived from Jaeger that Tempo on day one was 100%. Right, it's spot on. Tempo also from day one. It started on Parquet, and honestly, yes, we use Parquet, but we also everyone who uses Parquet ends up introducing minor changes. So are we perfectly universally compatible with Parquet? But it is a column store, right? So Tempo from day one was a column store, and that really helps, because one of the struggles that let's say Loki or Mimir have had is the metadata, the sort of resource data around OTel, and because if you think about it in traces, that makes total sense. You're going to send the trace, you're going to send the span. You've got these fixed number of fields. You've got some other fields that will actually vary, and it's a very, very structured signal. And most of the value of that is actually in the structure. Right? The actual trace is a tiny amount, but most of the value is in the structure. If we go on to profiles is incredibly structured, right? And so Pyroscope is able to take, say, the heap, the stack, and what is known from inside the application and inside the kernel and what's going on in the CPU and memory. That's very, very structured, and it's all very well known. There's a couple of formats for it, whether you're using pprof and so forth, but there's incredibly a lot of structure there. And they don't really have an OTel sort of metadata issue, in part because OTel haven't fully adopted everything around profiles at this point, but also in part because people who use profiles actually only lightly add metadata. You maybe have just application metadata at a very sort of light sort of line, and you might have, if it's like eBPF profiling, some information about the host. But people don't go beyond that because the actual structure provides such rich data that they didn't actually have to add more sort of enrichment to them. No, so profiles, once it's accepted, should be fine. Polar signals are doing great work there in that space as well. So Pyroscope and Polar signals together are really leading that sort of industry. Yes, I work for Grafana. Still willing to mention competitors.
Big ten. Yes.
Now, the more interesting ones are Mimir and Loki.
Yeah.
So Mimir, from metrics, let's just be clear, right? Prometheus is king. It's king across the entire industry. Right? It remains king. When we go to a customer and we say, "What are you doing for metrics today?" Some few will say Datadog, but the vast majority will say Prometheus.
Yes.
And whether that's Prometheus directly, and my gosh, we see some massive Prometheus out there. And whether that's Prometheus directly, or whether it's using like Mimir or Thanos or Cortex or Amazon managed or Google provided, and it's all Prometheus. And OTel is going to have to pry that out of people's hands on the value of the schema, the name schema, saying that's the signal you've left behind, let's bring it. But no one should underestimate the difficulty of making that change, because the Prometheus client, the remote write and everything else, it's so damn efficient. Right? When you run the OTel collector, it is not as efficient. And when someone's got a fleet and they've got like 10,000 machines, 50,000 machines, 100,000 machines, when you talk about efficiency, you're talking about, not just like, oh, it's only a couple of percent of the CPU on that one machine. You multiply that, and that is real dollars.
Yeah.
It's huge. So there's a lot that has to be done to really shift things. Now, OTel's metadata in a Prometheus store, and the state of Prometheus and stuff. At the moment, the metadata is mapped. Effectively comes part of labels, or you get it from the info sort of section and so forth. It doesn't handle the same volume and the same degree of enrichment. And that's, from the vast majority of use cases, that's fine. But if someone comes along with an SDK and they want every single field and they want to light up 300 fields, you're going to run into trouble. But I'd also question what you're doing.
Yes,
because if you're going to send 1 megabyte every like 10 seconds with a single integer, then I'm going to be sort of like, what do you value here? Because the OTel schema is absolutely phenomenal, and I love it. But I'm also just like, there is a trade-off and a tension here in what you want, because in metrics you want timeliness.
Yes.
Right? The alerting of it is your critical system, and that's a really important thing. Perhaps on your laptops, put that just in front of me, on a home machine or a Linux server, and you're for a hobby project, run this stuff. Who cares, right? Because it's a few points of some CPU core, and these are Apple, so the M1s or M4s, whatever. Just got to be like that, whatever. But when you do it at massive scale, the efficiency starts to matter, and so there's still a bit of issue there. And you're also having to retrofit. Right? You've got 20 years of code bases that were in Graphite, replaced by Prometheus. Prometheus is everything, and now you've got to retrofit and change all the instrumentation.
Yeah,
that's huge, right? And then when we go to Loki is far more interesting. The logs OTel stuff is far more interesting, because most log store were designed for essentially, I wouldn't say unstructured. Right? Unstructured stuff is what I type in WhatsApp, but log lines are semi-structured, right? They're always semi-structured. They have a timestamp, they have a log level or a HTTP method or a status code, and then they have some text at the end, right? But they're semi-structured, half-way structured. But actually, over time, if you look at the last decade, this wasn't like from ClickHouse didn't cause this. ClickHouse wrote it, but structured logs became more and more of a thing. Logs are interesting. People think they're just text, but they're not. They are logs existing multiple things. You do get sort of text logs, you do get semi-structured logs, you do get fully structured logs like JSON line logging or log bumped. But you also get like binary logs. Yes. And no one ever talks about that. No. Binary logs are what you have in databases for like transmitting stuff. They're still logs. But Loki and most other sort of log databases, observability use case ones, are based on semi-structured data. Someone's going to put a Python stack trace at the end, and you're going to have to deal with that.
Yes.
And so forth. Now, the OTel compatibility for that, if you look at how Elastic used to do things and why Loki came about, Elastic indexed everything.
It was efficient but expensive.
Yeah. Well, it also created some problem because they were indexing everything upon ingestion. Right? If you had a massively bursty sort of flow of logs, then there were times when the ingestion path cannot keep up. And at that point, the back pressure would cause like scaling issues, drop logs and so forth. And no one wants that, right? You've got to keep every log.
Yes.
So Loki's view originally was do as little ingestion as possible at that point, let everything in. And then at query time, we would brute force and do all the parsing and everything else. Right? And that was great. But, that was the best we could do and the best anyone could do, say, 5 years ago. Right? But now we're just like, well, actually, 5 years is a long time in tech.
Things change.
Right? And, ClickHouse and column stores do exist. Splunk got better too. Let's can't ignore the elephant in the room here. Splunk is the actual big player here. Loki's tiny. ClickHouse is tinier. Tinier, is that word?
Yeah, sure, yeah.
But Splunk is the market, right? And that's the one that everyone should pay attention to. But the capabilities did come along, and people now use their observability logs for far, far more than observability.
Yes.
Yeah.
Right? And that's the real thing, that when we think about the OTel stuff, we're actually thinking that they are enriching it not just with the actual normal OTel metadata, not just with all of the actual, these are HTTP logs and we're going to have all the dates. They're actually enriching it in addition with things like, and it's associated to this customer order.
And that's just joining with business data.
Yeah. We're flowing into a different talking point.
Yeah.
We're flowing into a different talking point, which is, in essence, the OTel added this pressure for structured capability onto the Loki system. And then at the same time, this rise in blending business information into logs. I use an e-commerce example of a transaction detail or customer ID, but it works across the entire thing, right? If you're a SaaS provider, you're going to add customer sort of tenant IDs in there or whatever, and you end up with support teams. They're not observability.
Yeah.
And they're coming along going, I want to look up everything related to this customer order because apparently the payment failed. Right? And they will search a couple of petabytes of data for a keyword, and it's like, that's painful.
That's we really need
Yeah.
We need some structure here.
Well, maybe we could just talk about like the state of OTel compatibility for all of the databases. Where are we at? We already said traces and profiles.
Traces spot on. Everything's good. Profiles, pretty damn good, because we're in those conversations. Dima from Pyroscope is in conversations with the OpenTelemetry people. The Mimir is. We're pretty good. We can actually do virtually most things at the moment, but we had a lot of upstream components which were in Prometheus, which means we also have to go and spend time with the Prometheus community to improve what they're doing and help support them in making Prometheus OTel compatible as well. And then Loki's probably the weakest, but it's not bad. Right? It's compatible, it's capable, but does it do absolutely everything? Well, actually, no vendor does.
Yeah.
But at the same point, it's pretty damn good.
Yeah, and also the user experience takes a bit to catch up.
Yeah. Well, OTel, it is important to say that OTel does not define the query language.
Yep.
Right? OTel does not define some of the user experience there.
Yeah.
OTel defines a protocol for sending it over the wire and naming and the sort of metadata sort of schema conventions. It doesn't define other things.
Yeah. So I think we're making progress for sure, but like there's a little things with Loki when you're querying on metadata that's like, oh, this could be a little bit better on an experience level. Maybe we could also talk about the architecture. We talked about Warp Stream and the new streaming architecture. This one's specific to Mimir. Jeroen Slot says, when do you expect to have Grafana Mimir 3.0 OSS with a new architecture available? And do you expect that Loki Tempo Pyroscope will follow soon?
Yes.
Okay. What about? But he's asking for a date.
Yeah. So
tomorrow.
So actually, versioning is an interesting conversation. But the Mimir 3 is effectively already exists, right? We run it.
Yeah.
So we already use internally. There's a code name for this, which is Sigyn. Sigyn is the wife of Loki, and it's the Norse god of integrity, which we take into be.
I like that. That's cool.
Yeah.
Data integrity.
We already have that deployed 100% in our production cells.
Not quite 100%.
Okay.
Right. So we're in the vast majority of our AWS and GCP sort of areas, but we're not yet on all of the Azure stuff. So slightly different speeds. So we don't put things in the OSS and say yes, it's stable until it's baked. Right? We're not
until we've used it.
So we're using it in Grafana Cloud. We monitor it. We work with it closely. we pay attention to what's happening. And when we say, yeah, that's totally something that, works, then we release it. But it's already available, right? You can already use it. There's an experimental flag. You can take some reassurance from the fact that we're running it in production. So in that respect, it's already available. But we do want to finish the Azure piece as well. Right? We do want to make sure it works across the top 3 cloud service providers, and then we'll cut that.
Yeah.
So that one's soon.
I think it's as you raised a good point there, and we had a conversation on this yesterday. It's between like different levels of adopters of our product, and it's like Mimir 3.0 is currently sitting in that very early adopter state phase. It's obviously all being contributed into our open source repo, and it's really for people to investigate, and those people that are confident enough to set up the new architecture, and then the documentation and how we want to do the proper release cycles will catch up when we feel more comfortable to do so. And
it's interesting. It obviously implements the Kafka API. And it should work fine with Kafkas, but we are predominantly using it with WarpStream.
Yes.
But it is the Kafka API. And we have very high confidence with WarpStream, and we're seeing very impressive numbers, not just in things like TCO savings, which will enable us to sort of be more competitive in pricing. But it's not just that, it's the reliability improvements are great. But there are some also there, I'll throw out some complexity to people and then people can deal with that. There are some issues, right? And one of the issues is nothing to do with Mimir 3.0, and it's to do with OTel.
Interesting.
So there is a Prometheus remote write by default enables like 50 concurrent sort of streams of data. Most of the OTel collectors and agents default to a very low concurrency. And when I say low, they didn't have any parallelizing.
Okay.
So they have one. And even though that they now support parallelizability,
I'm assuming they default.
Their default value is also 1.
Oh, great.
Wow.
So that's a problem. And it's a problem because when you introduce a Kafka and you've got a batch write, and a batch write, anyone who's used any Kafka knows a batch write takes about 500 milliseconds. So you have a tiny latency. It's imperceptible in the sort of I want to receive metrics within a second or two. Imperceptible at that level because we were already down in milliseconds anyway.
Yeah.
But 500 milliseconds to a client can be a backing up of data and can add back pressure. And because it's a continuous thing, that back pressure may never be sort of alleviated, whatever word. And so that can be an issue for OTel.
Interesting.
Right? So that's a pressure because when people deploy Mimir 3.0, they're going to have to think about their OTel agents, and they're going to have to make sure that they pay attention to the doc and increase the concurrency, the parallelization. But for every other agent out there, instantly concurrent parallelizable already. You're basically already doing like 50 or 100 with Telemetry to do 35 in their agent, and things like that means that there's no back pressure, no noticeable, nothing else, but there is back pressure in the OTel client.
So how about Loki, Tempo, and Pyroscope?
Wait, what was the question again?
The architecture, warp stream stuff.
Warp stream stuff. Oh yeah, it's on the screen like I read.
Yeah. Imagine that.
Tempos is all really quite mature, coming along, and because they already had the column store in place and they're just adding the warp stream stuff, theirs will be a quick follow. Loki's is a little bit harder, and
because of the columnar storage too.
Adding it on the front end is not so bad, but to take any advantage of it, we want to immediately add some components just behind, like dual writing some some storage sort of information, because for Loki team, adding that simplification and it is a simplification when you get an RF3 to RF1, you can think about it easier. So I mean, in that respect, adding that from a developer experience means that they can immediately take advantage of it to improve sort of creating column store type indexing of more of the structured data as it arrives. And so these they're not tightly coupled, but it feels like the best way to pass on the value of doing the change is to provide the feature that an actual end user can actually use. So that one's a little bit further behind. Pyroscope.
Pyroscope is the
interesting
weirdest one.
exception.
Yeah.
So Pyroscope is an interesting exception because it's not using
Warp stream.
As I said, engineers have very high autonomy and can investigate different ways of doing things. We don't dictate you must do this. And they felt in their case that what they had already in Pyroscope was so much of what was being covered by what Kafka would actually do, that they would rather do a small change in a different direction to reach that architecture, but that without requiring such a significant change.
Yeah.
And a third-party component. Or we spoke to a lot of customers who were just like, "Do you run a Kafka?" And everyone's like, "Yes." Right? And we spoke to OSS people just like, "Would you be willing to add a Kafka?" And people just like, "It's open source, yes." Right? So all of that is good, but Pyroscope has taken the different path of it's only a small change to actually achieve the same sort of guarantees, benefits, and trade-offs. So they've gone a slightly different way because they've essentially implemented a lot of their own versions.
Yeah. So
they might align in future. We'll see.
Okay. So if I understand it correctly, and correct me if I'm wrong, Loki, Mimir, and Tempo either already have Kafka Warp Stream or are looking into it as the solution.
Yeah,
but
Mimir
Pyroscope,
top, then Tempo, then Loki. Pyroscope.
Pyroscope just took that and they're trying to put it into Pyroscope rather than introducing another component.
So Pyroscopes is really, really interesting because it's not as, I guess the word is modular, and it's more integrated. It's a much richer, the benefits that they get from it are really quite astonishing. And it's a great experiment to run against two databases. Because we can actually see and trade off and go, which one's better? And perhaps in time we sort of go, the benefits of the deep integration are better. And perhaps over time we go, oh, the benefits of Kafka were better. Because Kafka offers other kind of things, which is like, let's say you're migrating from an old cluster to a new. Well, you could just adjust all your readers to point at the existing Kafka and you've done your migration. So you can, there's more flexibility that comes out of doing these things.
Yeah.
So I think it'd be quite good to jump back to this question that we had earlier, because we sort of talked a bit about the ingest, and now like we had a question about the storage later. And I guess another elephant in the room is columnar storage. It seems to be the trend on the block for absolutely everyone these days is let's have a columnar database, let's use columnar storage. How do you perceive, will our databases move into columnar storage? What are we looking into this?
Maybe let's read the question as well.
Good.
Hello, after using the LGTM stack for 2 to 3 years, my org is switching to ClickHouse as it was faster to generate analytics and reports, and compression is better as it can target the data type of each column. The team that introduced ClickHouse-based solution claims that they can build the service and wrappers around it so that the dev experience remains the same or simpler. What will be the future of LGTM? So it looks like they're comparing ClickHouse, a database with a columnar store, and talking about the advantages of that. They were talking about the analytical capabilities and saying that is something that the LGTM stack is not universally better at.
Also a big question at 8 a.m. Sorry, Dee.
Yeah.
Answering big questions before breakfast.
I don't know if the person's still online. I wonder if they're actually.
This is all recorded, so
So that means they're not online?
Oh, it means it doesn't matter because they can come back to it.
No, I want to ask.
Okay. Well, you can try.
I wonder whether the question is scoped just to the observability question or whether it's to all BI data that is being output. Because that's a really important distinction. When we consider column stores, you kind of got to go over the history of databases. The column store is not a new technology. This stuff's been around since the 70s, but actually people found it easier to actually work with relational. And you go back to Cobb and his sort of denormalized systems, and maybe it's not Cobb. Why have I got that name in my head? But whatever. I once learned something. So you go back to that, and people work with relational data, and it makes a lot of sense, but it has trade-offs. Right? You can reason about the data easier, but the trade-offs are that it's harder to query, and you'd end up creating these data warehouses to make it easier to do different type of queries. And there are two types of queries, and I'm going to mention them, and people can follow along. Which is you have the OLTP, and this is transactional. The T is transactional. Right? So this is basically looking at, think of select statements where you just get just your returning rows, but these are rows which are raw rows. And then your OLAP, which is the A is OAP, and the A is analytical. And these are where you add like a group by and you're doing sums and maxes, you're grouping. And SQL's interesting there because that made it really easy to explain. But these two types of queries are what drives a lot of why you would want to store things in a certain way. So Loki was built originally for the observability use case, where you're coming along and you're saying, I have a Linux server and something happened on that Linux server in this 10-minute window. And I want to go down and I want to find the row, the log line, where something went wrong. Right? So that's a transactional query. And the vast majority of observability use cases are transactional queries of that nature. And something like metrics would be used to identify the moment where you get a big spike. And then you go along with Loki and you say, for that query window, give me these log lines, right? Show me the errors there. And over time, the use of logs have evolved. And they've evolved towards, people, why do they want to look at dashboards all the time? But at the same time, instead of relying on, say, alerts or SLOs or driven by metrics or driven by traces or other things, they're actually just saying, we don't need metrics as much. We can derive our metrics from our logs, and we will use our logs to drive our dashboards, and we will make our dashboards from, all the logs we've got. And we wrote 50 terabyte of logs today, and we are going to make a dashboard that shows 30 days of logs. And it's heavily metrics driven. And it's heavily analytical because the dashboards are all count bys, sum bys, group bys.
Yeah, because you can't have actually all the logs.
And Loki was phenomenal at that. And actually, there were some other log stores as well, which are phenomenal at that at low volume. But they struggle when you start going, I've added to my log the transaction amount, right? Just the transaction amount, no PII, just sort of like we've sold £17. I'm British. I'll switch to a different language. It's 500 euros or whatever. And then
which
I'm the odd one out here.
Someone's converting.
Someone's got right currency converter in Grafana. And then they would plot these graphs which showed sort of like transaction value over time from the logs. And now they're doing business analytical queries from log data, and we're far from the observability use case. We've kind of strayed. And in that, Loki doesn't shine as much. So and columnar stores do shine, but there are trade-offs. There are trade-offs and tensions in everything we do.
Yeah.
It depends.
Well, that's the thing. It's not like one thing is better than the other. It's like better for what?
Well, if you are a company that has lots of different vendors in your environment, and you don't have control of how those log lines were being written, then using something like Loki remains the very best thing you can do, like by far, because you can take these semi-structured, sometimes fully structured logs, and you can basically apply these like real-time query time transformations to parse them and to produce these analytical queries, but the performance is not there. Right, every Loki user knows this, so I'm not going to hide the facts, right? If you run it at phenomenal scale, and you perform give me all the transaction amounts over 90 days, it's going to hurt, right? And you're going to get you're not going to get a sub-second answer. You're going to get like a 10-30 second answer, depending on how much resource you've thrown behind it. Now, if you own every line of software code that you are running, and you have full ownership, and you can change and retrofit all of your applications to use a fixed structure, and then you can express the fixed structure in a ClickHouse table or any other sort of column store type thing, then you have done the work manually as an engineer to define the schema, right? And you've set it, enshrined it, and perhaps you materialize some views of it as well. And at that point, because you've done the work to do I want these indexes, that's what you're doing when you're creating tables, you're creating these indexes, then the performance on analytical queries is phenomenal. That same question takes under a second. The catch, if you then want to go to your ClickHouse store, and you actually want to rehydrate all those lines, and you actually want to say, I was using it for, say, a security scenario, right? We took our HTTP logs and we turned them into a ClickHouse store. And that was our integral sort of like record of everything that happened. When you query and you try and produce an OLTP query out of a OLAP store, you effectively are querying all the columns and then restitching it back together.
Yeah.
It's expensive in another way.
It's very expensive and slowed in another way, right?
Yeah.
So there are trade-offs here.
Yeah.
And organizations that look at column stores have to consider these trade-offs. Do you store things twice, right? Was the actual log line important to you? In a security case, yeah. Right? What white space is used is critical to you.
Yeah.
Right?
Or like for a
not.
compliance use case too.
Yeah,
Exactly.
Right. So there are some sort of struggle areas as well. So you've really got to go back and understand what's going to happen inside the database. Is your data like really, really precious and it has to be fully retained in an auditable and sort of super secure record sort of thing? Do you care that it sort of comes out the same way? Do you care about actually, what's your use case? Are you querying predominantly an OLAP style thing or predominantly an OLTP type thing? Are you willing to accept the trade-offs there? And then there's halfway house, right? ClickHouse is actually really, really good. I won't damn it. I used it when I was at Cloudflare. So it's a great store. But you do need to know your trade-offs. You do need to know what it will shine at, what it will not shine at. And to most companies, if they come along with these questions, today I'm saying you probably want a mix of tools. Right? For your observability logs and for some of your other logs, you probably do still want Loki. Right? And if you have a heavy analytical sort of solution, and you don't need to really go down to log lines anymore, and you don't have some of these security or other scenarios, you would probably find that ClickHouse will fit. That said, we have a project. You're going to ask, right? So
Yeah, absolutely. We are looking into that.
So we have a project.
It's pretty early days still, though.
Yeah, and this is us learning. And it's us learning, so the Loki team is learning from Tempo. And Tempo have already shown that they can use Parquet as a...
learning, but then being like, nope, that's when we're not.
Actually, they're pretty close to being compliant on Parquet. But there were a couple of things where someone else was using Parquet, and that other people who use Parquet broke compliance and then knocked down one of our dominoes. But that was all right. But on the Tempo have had great success with column store. So Loki are now looking at a Parquet type storage. Well, Parquet is interesting. I'm deviating again. Whoever this person is down there actually been like, oh my god, they're all over the place. Parquet is interesting because Parquet file format as a column store is actually really, really good, and you also see all the benefits that ClickHouse column store has. ClickHouse, when you run it OSS, quite painful to run, but in their cloud they back it with object storage. That's nice, but they get all the benefits and they're not sharing that. But with Parquet, we will put it into not Parquet, but Parquet is defined for the file system. It's really good for seek actions. That's not good for object storage. Is this a level of detail which is too much?
No, they'll love this. We'll resurface you if we...
Yeah, it's fine.
Right, so Parquet is a format which has the index interleaved throughout the file, and it's really good for seek actions where you actually read forward, read the point, and then read forward. But it's not good for object storage, where you want to probably put a larger file down and do far fewer IOPS to the object storage to reduce your cost. At the moment, Loki's cost a little bit high, it can come down even more. And when you do that, what you really want to do is a fixed index sort of point, and then your data to follow, because then you could do sort of tables like partial block type fetching, because S3 and the object storage API that could do these sort of partial chunk type fetching out of an existing large file. So we want to write a large file, which is a column store. We're experimenting with this at the moment, which means I'm not promising it.
We're just about to have some breakout sessions on it, so that's the stage that we're at.
So we're performing an experiment of a Parquet derived format, which is more object storage native. to provide far more ClickHouse performance inside Loki for when Loki is used for analytical queries. That's the thing that's probably big news. But if
data objects.
Yeah, we're calling them data objects. But if anyone actually,
it doesn't have a cool name like Parquet.
um,
Oh no, are you going to come up with a name right now?
I will come up with a name on the spot.
Oh no. Well,
yeah.
that person that whose question we were answering, MZS114, says they agree with Loki's strength for flexible log format. As we have thousands of microservices, the plan is to use vector to do the transformations. And there's a plan to standardize log formats and fields. So looks like observability use case, in which case Loki still shines.
It still shines merely because of that read use case, right? If you're actually primarily concerned with the analytical queries, like just seeing dashboards of logs over time, then this ClickHouse will do that better. But when you're actually using it in in an instant, you're doing the instant response, and you're trying to go down to individual log lines, then you get annoyed that it's not as fast.
I just wanted to raise the other point in that. It was an interesting one, and I think again it's down to like trade-offs, where they were talking about, well, we're going to build a series of APIs on top of ClickHouse that makes it feel like you're using LGTM underneath. And I think that is one thing to keep in mind, and maybe to ask the people that are implementing this for you. The trade-off here is you need to convert those queries into SQL. So if you're using PromQL at top, if you want to use the services on top of Grafana, those services that you want, that you used with like Prometheus and Loki, you need to convert them. Depends how well they develop those APIs in order to use the speed of ClickHouse efficiently.
Actually, that's an interesting thing, query languages. I'm sending your talking points all over the place.
So,
well, actually, maybe we could, because we only have less than 10 minutes.
Oh,
so maybe we could.
Wow.
Yeah.
I still would really love to talk about adaptive telemetry and the drill down apps. So maybe we could go through the state of adaptive telemetry for all of them. So adaptive telemetry, for people that don't know, maybe you should actually describe this.
Should I?
Yeah. That's what you're here for. We're here to ask you the question.
Adaptive telemetry is a Grafana cloud feature. It's not an OSS feature.
Yeah.
We should start with that clarification. And the purpose of adaptive telemetry is, let's step back and go, what's the problem with observability? And one of the large problems is that when you were in the monitoring world and you would add you would add monitoring to answer specific known questions. And with observability, you're adding a lot of instrumentation so that you can answer the known questions, but you can also, in the time of an instance, answer your unknown questions. So you're gathering far more information, and it gives you this ability to reason about what's happened and everything else. But that means that the volumes of data have exploded, and your costs too have exploded.
Yeah.
And you might only still be reading a similar amount of data to what you used to have. So your value hasn't gone up, but your cost has gone up. You aren't using it anymore, but your cost has exploded. And there must be some way, some people will come along and go, I want a quota. I want to say that you cannot write more than this much logs, or you cannot go above this many active series in a Prometheus world. And the problem with anything that is a quota is everything is equal, which sounds wonderful until you stop and then go, damn.
Yeah.
And what happens is that if a quota were kicked in, let's do metrics because it's the easiest thing to think about. If a quota was kicked in and we said, right, we exceeded some 100 million active series, are these numbers too high? I don't know what customers, open source users, we see customers at like hundreds of millions of active series.
Say 100,000 series is probably a good good open source.
But still, so even at 100,000 active series, right, you perhaps don't want to spend on 150,000. So you put a quota in and say, at that point, throw away everything above this. Now that's crazy, because one or two things are going to happen. Either your quota is time-based and you consume for the first 2/3 of an hour, and then you just go, we're going dark the next third of an hour. Or you're going to say, we're applying this quota continuously, and anything above is dropped, but everything is equal. The critical signals that you're going to use, the critical metrics and labels that you're going to use, may go above the quota and be the ones that are dropped.
Yeah.
And what you really want is some way to prioritize. You want to say, this stuff is really important to us, but that stuff isn't. Right? And so when it comes to receiving the data, you want to keep the important stuff and say, if I've never queried it, and I never ever use it, and it's
Yeah.
not in an alert, and it's not in a dashboard.
Am I just hoarding?
Just am I
Yeah.
a data hoard?
Yeah.
You know, and am I going at home and there's boxes of data everywhere?
I printed all the log records out.
So adaptive telemetry is a system that we first introduced in metrics, and now we have in logs, and we're working on the others. And adaptive telemetry is a system that reads the usage of all of the telemetry based on some criteria. For metrics, it's whether it appears in dashboards, you're querying it, you query it via the CLI, you put it in alerts. It has a proximity to a time and event, like something going wrong in a machine. And that's all important for gradations of importance. And that stuff will always be kept. And then you have the ability to manually or automatically say the unimportant stuff, aggregate it, discard it, whatever. And what that does, it means that you can observe everything, you can instrument heavily, but you don't have to have this sort of sticker shock of the price at the end of it. And that means that your costs are under control, but ignore the costs. What it really means is that your value is very high for the cost that you are paying. Right? And that's the real sort of benefit of it. In Loki, that's based on patterns, like logline patterns. And we're currently looking at, we are going to complete the family, right? Whenever we learn something from one database, which is really good, the other teams listen, they learn too. So we are working on adaptive traces. I don't think that's a shock to anyone.
No.
And
we talked about it just in GrafanaCon too.
Yes.
Yeah.
That's good.
Yeah.
And profiles,
fine.
adaptive traces
Yeah.
and profiles
Great,
are
I
out.
mentioned the
Yeah,
other one.
yes.
So we are working on adaptive telemetry as a full family thing. But it is in Grafana Cloud only, and it's not OSS because of the massive integrations across all of the systems. This isn't you could use Tempo by itself and gain adaptive traces, or you can use Loki by itself and gain it, because for us to understand usage, we have to see everything. And that's very much a very deep integrated thing.
Yeah.
So,
and it's like we're also sinking the own cost of running these services that are basically checking whether you operate like the algorithms that we're running to make sure that your data is ready for adaptive.
So in Grafana Cloud, we give that for free.
Yes.
Right. Well, you're paying for Grafana Cloud, and when we added these features, we did not charge you more for these features, even though it lowered your bill.
Yeah.
Right. So that's an incredible thing, but it makes customers happy. Right.
And that's it. That's the point. Is that we want them to be with us for these reasons. We want them to trust the fact that we know what we're doing with your data, and
well, it's also for us. Like, this isn't. We also use this. We also want to lower our costs.
Yeah,
we also want to increase our value. Because we use all our own stuff. So we want this for ourselves. So why would we then not make it available to other people?
Exactly. And so some of our own systems, we use all this stuff with automatically applying rules across all of our signals, which will probably terrify some people.
Ninja Sloth has a question just on this. Adaptive metrics or inline aggregation seem to become a necessity at scale. Has there ever been talks about this functionality in OSS, but with more manual user-generated aggregation rules like M3?
Yes.
Sure, there are talks. How to do it is a little bit more tricky.
So that's really interesting as well, because M3 added that functionality, and we were inspired by that, and that was caused us to go and actually say, what can we add? But M3 haven't innovated on that in the OSS anymore, right? So they've actually put all of their secret sauce back into their own database, and that's the proprietary stuff. Whereas we've taken the capabilities that we've actually built, a lot of it is in there, but we haven't yet surfaced it externally. Now, I actually do think that we will eventually, no date, eventually have to come around to this, because I do think that there is similarities here with other. For me, one of the forms of innovation is to see something in a different space and bring it over. And for me, this is very much like in a firewall or a WAF rule or something, where what you actually want is it's a rules engine, right? And a rules engine. These are common in other parts of tech, and we should possibly be looking after we've got them to a decent maturity to align them in some way to actually say rules transformations, aggregations, enforcement should happen closer to the edge, and we could investigate that. But that's a very open future.
Yeah,
There's
yeah.
no commitment there.
Yeah.
That it feels like in a year or two we will be approaching this point where we say we've got it to a point where we would consider trying to align this and now surfacing it.
And that's not to say you couldn't create like a poor man's version with Prometheus with something like recording rules
Yeah.
or something like that, where you could take a much more extensive data, generate some recording rules, and bring them into a more central way of doing it. Mimir.
No, why do we do this in cloud and not in OSS? And part of the reason is the innovation speed, right? If we put this in OSS and you all used it, and you would use it, we would not be able to change it, right? And if we got something wrong, we cannot fix that. Right?
Yeah.
We baked it in, right? And it's going to be wrong. It's going to be painful. It's going to be a horrible experience.
Yeah.
And you're going to experience us throwing away everything you just built on, right? So
And-
we don't want to do that. So we build in cloud. We make our mistakes, right, mostly to ourselves. And then you say it's stable enough. It's
Yeah.
I think we can do that. Can you stop your camera? I think we're still going on mine at least.
Is that still broadcasting?
Can you stop your camera?
Yeah, I can just remove myself.
Well, that's interesting. When you're
So we're right. Yeah. So it's just killed me.
So what I
Ninja
said
Sloth was
did get out,
saying,
right?
And then scrape time aggregations for the likes of an ally component to keep these closer to the source.
Yeah.
I mean, you could do it at different levels, but I mean, I think if the point of adaptive telemetry is to lower costs, increase value, you can do that at multiple layers. So you're talking about doing it on the collector level. You could go further back. You could do it like if it were logs or something. What should be logged? What shouldn't be logged? There's education that's around that too.
I disagree with that, because
What?
then you're actually taking a regression back towards monitoring, and you're only going to have the signals that are in the code, the instrumentation.
No, I'm
For the
talking
questions
about like logs that you don't really need. Like there are a lot of people who still do who print to log, and there's just some console logs
Sure.
that are not.
But if adaptive telemetry throws that away, and then during an instant you said, I really needed this, I tried to query it, then we can unaggregate it, we can undrop it, right? And Tempo has this ability that did we announce it?
I do not.
Because we introduced the warp stream component, we can consider things like recent replayback.
Yeah.
Right. So if there was a rule to drop things, and then someone started querying, perhaps we can just go back and put the Kafka client to read earlier and replay that bit and then put it back out, even though it's supposed to be aggregated. So even in an instant, you can immediately get it back. Right. So adaptive telemetry is way more mature, sophisticated, and capable than merely performing aggregations hard-coded at any level, because it's dynamic.
Yeah. I just know from load testing that sometimes people just want to keep absolutely everything, like every request they want to return in a log line, the entire response body of every single request for
response body.
Yeah,
that's PII nightmare.
Yeah.
Literally.
So it has to be at all levels, and not all of it is adaptive telemetry. That is one of the layers. But you could also, if you're trying to get more value out of it, alerting, like you said, you don't want to be looking at a dashboard forever anyway. Sometimes people have all the data, but they don't have the alerts on it. They might even have a great dashboard.
Humans are the weakest link until you actually have to respond to the instant.
Yeah.
And then humans are the strongest link.
Yes.
But also to the point of why don't we OSS this? We were just in a talk yesterday, an internal talk, where we were talking about how much hand-holding it takes to even get a team to say yes to we will drop your logs. Yeah. It's not. It feels like a disservice to just put that out in the world and not support it at all, and not walk you through here are the ways that you can kind of tweak it.
It's interesting, right? So what do we OSS? We OSS actually everything. Right? But what we're OSSing is like all of the capabilities, the building blocks, and you can pick and choose. You can compose the solution. But some of the very deeply integrated, very opinionated, this is how it will all come together as a very tight solution, that isn't OSS. And a lot of that's to do with that we have to learn ourselves, we have to carry on innovating, we have to be able to like not calcify it, sort of fix it in this moment in time, and sort of just have it sort of accrue into a fixed state. We have to be able to evolve it, and the best way to do that is in our own cloud. So there is a real tension there between what we do open and what we don't. But I do think, going back to the question about opening it up and everything else, I do think we will reach a point where that is not fundamentally a sacred thing. It's not changing very quickly. We can know what the capabilities should be across all of the signals. We can build a rules engine that would work across all of the signals, and then it has that essence like a WAF, where WAFs don't care what the application is. I think there is a space that eventually that will come, but there'll still be stuff which wouldn't come with that, like all of the back-end weird stuff is deeply integrated into Grafana Cloud that tries to find out what you use, when you use it, and how to recommend the rules. That probably wouldn't be, because that's so deeply integrated. Some of that's even integrated into our billing system. We're not shipping our billing system.
Yeah. Okay.
So I'm going to be the bad guy because we are over time. We've got places to be. So yeah. So taking this all from the cache brain, let's see if we can summarize what we've done so we can finish up. So we've talked a bit about the new architectures that are potentially coming in. One has already come in from Mimir. We've talked about the power of Kafka, especially during ingest. We've theorized a lot around columnar storage and Parquet. We've talked about the future of OTel with all of our databases and the state of where we're at. And then we've talked about our adaptive telemetry and where that future might go as well. But not to be, that was theorized once again.
Was there anything else that you just wanted to throw out there, future directions?
I think we went in enough directions.
You revealed enough.
How to come up with names for things.
Yeah. Every project, every implementation for every database is different.
The naming of things. So Sigan was the name of the Warpstream project, the Kafka project with Mimir. Loki have decided Thor.
Love it.
Obviously, Thor being the sort of the brother of Loki and being even stronger and more well behaved and everything.
And then Tempo's like,
Tempo
no.
called theirs Rhythm, because there's like the best way to be like a good drummer and having tempo.
That's so good.
To rhythm, and I'm just like, I can't keep track. We should leave them on that note.
All right. Thank you, everyone. We'll see you next time. Thanks for watching. And thank you, Dee, for also joining us.